Students, welcome back to school on Wednesday morning. Sorry about that. Hope you guys had a good day yesterday and a good night last night and ready to learn some more math. Let me glance at my notes very quickly, please. As I mentioned yesterday, there'll be no test or quiz this Friday, so enjoy that day off from tests and quizzes. You do owe me yesterday's homework, so please turn that in right now. I hope that you're not getting behind. So please turn your homework in at this time. There was a video for you to watch, and hopefully you took advantage of that. Terry, you owe me a test by Friday, okay? So be sure and get with Mr. Harmon on that. He has the test, and it's your job to make sure you take that test by Friday. I've been trying to give you guys some more bonus points, and so I'm going to do that now. Please grab your books. And remember, I'm going to teach the whole hour. In fact, I think the videotape might be longer than the actual class period. I'm not sure. I have tried to time it. I've got a stopwatch running right now. But if that's the case, just watch as much of the video as you can, and then you do. I mean, if you don't finish it, don't worry about it, because we're just doing a bunch of problems today and practicing. Okay, so watch the whole video. If you don't finish it, that's fine. Remember, I'm not going to teach tomorrow. So watch this video up until the bell rings, or until the video finishes, whichever comes first. And if you do not finish the video, you do not have to watch the rest of it. And tomorrow there'll be no notes, just a homework assignment you're going to work on the entire hour. Now, right now, I want to give you some bonus points, so hopefully you're ready for this. Please turn your books to page 361. We're going to do numbers 3 through 8. Each one that you get correct, I will give you half of a bonus point. So at this point, you will want to pause the video, and when everybody is finished, then restart the video. Okay? Okay, numbers 3, 4, 5, and 6, they asked you to reduce the ratios. I'm looking in my book now for the exact wording that they used. Simplify the ratio. So hopefully if you simplify this correctly, you realize 2 goes into both of these, so this should become a 6, and this should become a 5. So the answer is 6/5. If you wrote meters up top, that's fine. If you did not, that's fine. Okay, let's see. 7 goes into both of these numbers, so hopefully you made this a 3, and hopefully you made that a 5. 7 goes into both of those numbers evenly, and if you put 3/5, that's fine. If you put pencils, that's fine. Now, on this one here, I'm going to accept 2 answers, either one. I told you guys in my class, if you have different measurements in the top or the bottom, you do not have to convert them. I really don't care, but some of you might have taken 2 years and wrote this: 24 months over 6 months. And if you did that and then reduced it, you would get 4/1, and that's fine. If you just took these two numbers, the 2 and the 6, and you just reduced them, and you put 1/3 years and months, that's fine. Either one is fine. Okay? Alright, same thing with this problem down here. Let me put a little dividing line here. You could have done this one 2 different ways, okay? You have yards and feet, and we all know that 1 yard has 3 feet, so 2 yards has 6 feet. So some of you might have put 6 feet over 16 feet and then reduce that, and if you did, reduce by 2, you get 3/8. I have no problem with that. Or some of you might have just taken these 2 numbers right here and just reduced them, and of course if you did, you got 1/8. I will accept either one of those 2 answers. Okay? Alright, let's continue on. Let's take a look at number 7. Number 7 told you the ratio of FG to GH is 4:3. Alright? And then they tell you the entire length of FH is 56. So 56 runs all the way from H all the way to F. Alright, now they want us to do this. They want you to find the length of FG, and they want you to find the length of GH. Sound effects again. There we go. Alright, now FG, we're going to put an X right here and an X right here. Those are the 2 lengths that we're looking for. Of course, FG the ratio is 4 to 3, so for FG I'm going to put a 4 with the x, and over here I'm going to put a 3 with the x. Alright, now you should know by now, if I take this total length right here, FG, and I add this total length, GH, it should equal the entire length, which is FH. So FG is 4x, GH is 3x, FH is 56. Combine those two terms. 7x equals 56. Divide both sides by 7 and x equals 8. Now if you stopped right there, don't give yourself any bonus points. That is not your answer. I wanted to know the length of FG. So FG is Fx, where the x is. I'm going to put an 8 right there in parentheses. 4 times 8 is 32. And then for GH, I'm going to come up here and I'm going to put an 8 right here where the x is, and 3 in parentheses, and 3 times 8 is 24. Each one of those is worth a half a bonus point. So let's review real quick in case you're confused. Half a bonus point for 3, half a one for 4, half a one for 5, half a one for 6. And number 7, I'll actually give you a half for this one and a half for this one to try to help you out a little bit. Okay? And then moving on to number 8, and I believe this is the last problem that I had you do. Alright, sorry about that pause. Hold on one second. Alright, here we go. The perimeter of this rectangle is 27, and the length to the width is a ratio of 2 to 1, and they want us to find the length, the measurement of the length, and the measurement of the width. Now, here's the length, we're going to call it x. Here's the width, we're going to call it x. The ratio is 2 to 1. So I'm going to call my length 2x and my width 1x. Now come on, let's think about this. In order to find the perimeter, I've got to take length plus width plus width. In other words, this is going to be 2x and this is going to be 1x. So if I add all of those up, guys, if I take 2x plus 2x plus 1x plus 1x, if I add up all four sides, that should equal the perimeter. And I know what the perimeter is. The perimeter is 27. There we go. So 1, 2, 3, 4, 5, 6. So 6x equals 27. Divide both sides by 6. And you should get, let's see, 4 and a half, or 4.5. I don't care if you have 4.5 for x. Now that's not your answer. Let's come up here to the length. The length is 2x. And so where the x is right here, I'm going to write 4.5. And 2 times 4.5 is 9. And then for my width, it's 1x. So where the x is right here, I'm going to write 4.5. And 1 times 4.5 is 4.5. Each one of those is half a bonus point. Each one. Okay? Alright, get caught up, quickly finish your bonus points. Remember, my goal is to go fast, and you can pause the video when you need to. Okay, that's how we're going to do things, so I'm going to keep moving. Alright, your heading today is this. You should have your notebooks out. You should always be ready to take notes as soon as the class period begins. And remember, I'm teaching for a marathon today, but I will not teach tomorrow. I'm going to give you homework tomorrow. Please copy this in your notes. We are looking at something new today that you've never had before, so please give me your undivided attention. We are looking at similar polygons, okay? Similar polygons, not congruent polygons, similar polygons. Lesson 7.2, and the date today is the 20th. The 20th, okay? All right, copy that down, and let's move on. Now, let me slide this down. I want you to copy some stuff in your notes, please. First of all, I'm going to use a tool very quickly here. Just be patient with me, please. All right, still waiting for this thing to pop up. And there we go. All right, now, all right, that's not what I wanted to do. All right. Now, Would you please copy these two rectangles in your notes? Go ahead and do that quickly, please. Copy those two rectangles in your notes. Copy down the lengths, 2, 2, 3, 3, or the lengths and the widths of these two triangles. Now, as you're copying these down, would you please listen to me? Do you notice how all four angles here are congruent to all four angles over here? 90, 90, 90, 90, 90, 90, 90, 90. And then notice how this side is congruent to this side, and this side is congruent to this side, and this side to this side, and this to this side. What do we call these two rectangles? Come on, guys, we know this. What do we call these two rectangles? They are called congruent, right? We learned that congruent polygons, you might want to write that down. That would be very intelligent to do. We have learned that congruent polygons have congruent corresponding angles and congruent corresponding sides. We know that. All the parts are the same, and so thus they're congruent. But now I'd like you to put something else into your notes. Okay, you ready? I want you to write these two rectangles in your notes. Would you please? Copy these two rectangles in your notes. Notice that this rectangle has widths of 2 and 2 and lengths of 3 and 3. Over here it's 6 and 6 and 4 and 4. And one thing I did forget to put, and that's my fault, are the right angle symbols. We do have a right angle here, and we do have a right angle here, and we do have one here, and we do have one here. Okay? Now, please watch this carefully. We know that these two rectangles are not congruent. That's so obvious. Are all of the parts congruent? Oh, Mr. Hart, the angles are congruent. Yeah, I know, but are the sides congruent? The answer is obviously no, they're not. And so these two rectangles are not congruent. But you know what they are? Would you look at something? Do you see how the 2 right here increased to a 4? And do you see how the 3 increased to a 6? Didn't they increase by the same multiple? Didn't I take 2 and multiply it by what? 2 times 2, and that's how I got a 4 here. And see this 3? Didn't I multiply it by the exact same number? 2, and that's how I got a 6. Well, whenever you have two polygons, please don't miss this, and take notes however you need to. I'm going to give you a definition in a second. But whenever you have sides that are increasing by the same multiple and their angles are congruent, here's what we call those two polygons. We don't call them congruent, but we call them similar. And you know what the symbol is? Look up here. This is our congruent symbol, right? Well, here's the similar symbol. Just like that. That's it. Wow, you impressed? Let me do it again. Wow, there it is. Okay, so these two triangles are similar, and that's the symbol you would use. So I wanted you to see that before I gave you a definition. Please copy this definition in your notes. Please copy this down. Similar polygons are two polygons that have congruent corresponding angles. Do you see that? And proportional corresponding sides. That is a definition you'll need to know, and I'd like you to copy that down. And then I want to show you something I think is very, very important. So please copy that definition down. And once you're done copying that definition down, I want you to draw these two triangles in your notes. Now, again, for the 100th time, my videos are set up so that you have to pause them sometimes, okay? You can't speed me up, but you can always slow me down. So I'm going to keep moving, okay? If I'm going too fast, just have someone pause the video. Copy these two triangles down, please. Triangle ABC and triangle DEF. Notice the lengths over here are 6, 7, and 4. Notice the lengths over here are 12, 14, and 8. Do you see that okay? Now we know that these two triangles are not what? There's no way they're congruent. There's no way. They don't have all the parts congruent. I mean, this side's 6 and that side's 12. But look what you have, and this is what you must have for similar polygons. Are you ready? Watch the red marker. Two polygons are similar when you have what? Congruent corresponding angles. Let's see if that's true. Do you see this 40 here? What do I have right here? 40. Booyah. What do I have here? 92 degrees. What do I have right here? 92 degrees. See this 48? What do I have right over here? 48. So far, these two triangles are similar because they have met the requirement of congruent angles, congruent corresponding angles. Now, look at our definition. They must have proportional corresponding sides. Proportional corresponding sides. Well, here we go. Let's see if we got that, okay? See this side right here? It should go over this right here. Those two sides are the same. So I can write 6 over 12. Do you see how we do that? All right. I should have got rid of the circles first. All right, so 6 over 12. Now, it doesn't matter which side you go to next, but 7 obviously corresponds with 14. Do you see that okay? So I'm going to write 7 over 14. Now, side 4 obviously corresponds with side 8. Okay? And I did not mean to do that. I do that a lot, don't I? Side 4 obviously corresponds with side 8, so I'm going to write 4 over 8. Now, I have a question for you. Were these angles congruent to each other? Yes, they were. But are these sides proportional? Well, let's find out. All three, if we have true similar polygons, then all of these fractions should be the same. Let's put equal signs between them, and now let's reduce them. 6 over 12 is 1/2. 7 over 14 is 1/2, and 4 over 8 is 1/2. Cool. Okay. Now look. This has got to be true, or you do not have similar polygons. Got it? You must have two things. Two things. Number one, you must have congruent corresponding angles. And then number two, you must have proportional corresponding sides. And what does that mean? That means when you write the correct side with its corresponding side into a fraction, and you must do that with all the sides, and you reduce all of your fractions, they will be equal. If just one of them's wrong, like this is a 2/3, then the two polygons are not similar. Okay? They must be the same. I hope that helps a little bit. All right, let's continue on. Let's take a look at a problem here I'd like us to work on, okay? I would like you to copy these two triangles down. Don't worry about this right here, right now. This number one is copy these two triangles down. Triangle TSU and triangle RPQ. And copy down the dimensions, 8, 12, and 16, 10, 15, and 20. And look what I've written here, students. I have written for you triangle PRQ is not congruent, but it's similar to triangle STU. Okay, I've written that down. Now, if I hadn't written that, you would not know that these two triangles are similar. Really, Mr. Harris? Well, yeah. I mean, how do I know that this angle here is congruent to this angle here? I don't know that. How do I know this angle is congruent? I don't know that. So, really, I had to state this. But now, watch carefully what I do. These two triangles are similar. I'm telling you. So here's what I want you to do. I want you to list all the pairs of congruent angles. Remember, when two triangles are what? Similar, then their angles are what? Congruent. Are their sides congruent? No, but their angles are congruent. So I would like you to go ahead and list out for me the pairs of congruent angles. Are you ready? Here we go. What letter's first here? P. And what letter's first over here? S. So we know angle P is congruent to angle S. Once you go ahead and mark that. So put 1/ here. 1/ here. Second letter is R and the second letter is T, so we know angle R is congruent to angle T. So let's put 2/ here and 2/ here. And then we know the last letter is Q and the other last letter is U, so Q is congruent to U. So 3 slashes there and 3 slashes there. Does that make sense to everyone? When I tell you that two triangles are similar, their angles are congruent, so you should be able to list them. Their sides are not congruent, but their angles are. All right. Now, using those same two triangles, now I want you to do this. Can you write the ratios of corresponding sides in a statement of proportionality? And you're like, no. Well, let me show you how to do that. Okay. So here we go. Watch carefully how I do this. What two letters come first? PR. What two letters come first over here? ST. So I can say PR goes over what? ST. There we go. All right. I said if you erase those lines first. So PR over ST. Now, see these two letters here, RQ? Well, they go with TU. So we say RQ over TU. And now the first letter is P, last letter is Q, so PQ goes over SU. Now let's go back a page. Remember how 2 pages. Remember how I showed you when you write your one side here with its corresponding side over here as a fraction, and then when you reduce those two fractions, when you reduce all your fractions, they should equal each other. Well, what can you put between all of these fractions? Equal signs. Because look what you did. Watch. Please watch this, student. See PR? Here's PR. You put PR over what? ST. That's fine. And then you put RQ over TU. And then you said PQ over SU. So there we go. You wrote your statement of proportionality using these sides. Now, I'm going to copy this, so give me a second to do that. Let's come over here. All right. I want you to do one more thing. All right, number 3. I want you to write the ratios now with numbers and make sure they are congruent. So are you ready? We're going to take the statement of proportionality that you just wrote, and now we're going to put numbers in. So PR. Where's PR? Here it is, 10. So for PR, I put a 10. And what goes under PR? ST. ST is 8. Then I put an equal sign. Okay, RQ. Where's RQ? Here's RQ. That's 20. And what goes under RQ? TU does. So, where's TU? Here's TU. That'd be a 16. And then PQ. PQ. Here it is, 15. And then what goes under PQ? SU does. So let's find SU. Here it is, 12. Now, drum roll please. If these two triangles are truly what? Similar, which we were told they were right there. We were told they're similar, okay? So if they're truly similar, then all these fractions better be equal when we reduce them. Well, if we reduce the first fraction, we get 5/4. If we reduce this fraction by 4, we get 5/4. And if we reduce this fraction over here, we would get, let's see, 3 goes into it, 5/4. There we go. And that's what should happen. Do you see how this works, students? The sides are proportional, okay? When you reduce them, you're going to get the same fraction out if the triangle or the polygon is similar, okay? All right, let's continue on and try another problem here. Now, I want you to do this for bonus points, all right? So here we go. For a half a bonus point, just a half, I want you to list all of the pairs of congruent angles. Now I made a mistake and I'm sorry, so please copy this down. I should have wrote KJML is similar to PNRQ. There we go. Can you see that okay? So go ahead and I'm going to wait just a second for you to do that. I'm not going to have you pause the video. I'm going to count to about 10 in my head very quickly. I mean, you should be able to do this. List out the pairs of congruent angles. You must get all of them right for, we'll say, 1 bonus point. Okay, I've stated right here that the two polygons are similar, and so because of that I can say angle K is congruent to angle P, angle J is congruent to angle N, angle M is congruent to angle R, and angle L is congruent to angle Q. Do you see how I did that? K would go with P, J would go with N, M here would go with R, and L would go with Q. Okay, so all of those right for one whole bonus point. Are you getting this okay? I hope you are. We're going to do a bunch of practice until you're about ready to pass out, okay? Tons and tons and tons. Okay, using these exact same drawings, I'll have to write this for you again. I want you to write the ratios of corresponding sides in a statement of proportionality for one bonus point. And I'm going to go ahead and write this for you right now. K, J, M, L is similar to P, N, R, Q. And by the way, if you do it correctly, I'm going to help you right now. You'll have a fraction with an equal sign, a fraction with an equal sign, a fraction with an equal sign, and a fraction. You'll have 4 fractions. Now I want you to get the bonus points, but more important than the bonus points are you actually understanding this, okay? So hopefully you'll get this right, but if you don't, take notes, pause the video, ask your classmates questions, and listen, okay? So I'm going to go ahead, do not pause the video, I'm just going to count to about, I don't know, 15, 20 seconds here, and I want you to write the ratios of corresponding sides in a statement of proportionality. And by the way, we're doing it like this right here. Right here. So if you want to use that to help you in your notes, that's what we did. Okay, my first 2 letters are, let me get a different color here. My first 2 letters are KJ and PN. So I'm going to say KJ over PN. Alright, now my next 2 letters are JM and NR. Do you see it? JM and NR. So JM, NR. Alright, my next 2 letters would be ML, RQ. And then my first letter is K, my last letter is L, and over here my first letter is P, my last letter is Q, so K, M, and that's incorrect, I apologize, KL over PQ. So there, you did it. Well, hopefully you did it. That is your statement of proportionality, okay, right there. And I'm going to have to go ahead and copy this and take it to the other page real quick, so give me a second to do that. And if I'm going too fast, like counting to 20 seconds, and you need more time, pause the video, that's fine. I don't mind that. Hopefully you understand that. You're welcome to give yourself more time. I'm just trying to keep things moving. So, all right, now for one more bonus point. And I told you guys in class I'm trying to give you more of these chances. So for one more bonus point, now I want you to write the ratios with numbers and make sure they are congruent. So for only one bonus point, you're going to make substitutions like KJ. Do you see KJ right here? Well, I'm going to go ahead and help you. KJ is 2, so you put a 2 right here. All right, go ahead and write all your fractions, then do one other thing. Are you listening? I want you to reduce each fraction, and they all had better be equal. Okay, so I'm going to go ahead. I've got to get rid of this circle. There we go. I'm going to go ahead and look at my stopwatch here. I'm going to let the clock run for about 30 seconds, and then I'm going to start working on it. And you can either pause the video, or if you're over here and I'm over here, you can probably just keep working. Okay, but I'm going to give you about 30 seconds. Students, please remember, if you're still working, you can pause the video, or if you're over here somewhere, go ahead and keep working, okay? Because you're done with this already anyway. So, all right, KJ would be this, PN would be this, equals, JM would be that, NR would be this, ML would be this, RQ would be this, KL would be this, and PQ would be this. All right, well, let's see here. Are you ready? We cannot, let me get some room to work with here. All right, we cannot reduce the first fraction so it stays 2/3. Bring down our equal sign. We cannot reduce this fraction, it stays 2/3. Now, 4/6 is easy. 4/6 becomes 2/3. Now, you might not have known what to do with this here, and if you don't get a bonus point, you don't get a bonus point. It's not the end of the world, okay? But I don't know if you knew this or not. You're welcome to move a decimal in the bottom of a fraction as many places as you want, okay? I don't care how far you move it, as long as you move the decimal on the top the same amount of places. So I'm going to move this decimal one place. Why one place? Because that now gives me a whole number of 42. But if you move this decimal one place, then you got to go up top and move this decimal one place also. So 2.8 over 4.2 is the exact same thing as 28 over 42. And now we can reduce this, okay? 14 goes into both of these numbers. 14 goes into 28 twice, and 14 goes into 42, yes, you guessed it, 3 times. So yes, this does reduce to 2/3. This was a very hard problem. If you didn't get the bonus point, you didn't get it. It's no big deal, but that's what I wanted you to do. Okay, let's review very quickly, please. I want you to be able to list out congruent angles when I give you a similar statement. Okay, I want you to be able to write out the statement of proportionality using the letters of each side like we did here, and then I want you to be able to actually write out the numerical fractions like we did here, and then reduce each one and make sure they're congruent. Okay, that's very, very important. Now let's continue on and talk about something else you need to know. You need to know about a scale factor. Would you please write that down? You need to know about a scale factor. This is extremely important. You'll need to know this definition. And let me explain to you now what a scale factor is. I know what the words say, the ratio of the lengths of two corresponding sides. All right, but let me give you a picture of this that I think might help just a little bit. So let me slide this down. Okay, copy this in your notes, please. Scale factor, the ratio of the lengths of two corresponding sides. Okay, let me teach you what a scale factor is. That's the word, that's the definition you need to know. Here's a good example of this. All right, I want you to copy these two triangles in your notes. Would you do that quickly, please? I should have put this, go ahead and put this symbol between them. I should have done that. These two triangles are similar, and I think you need to go ahead and put a 1 mark here, 1 mark here, 2 marks here. I should have done this. I apologize to you. 2 marks here, and 3 marks here, and 3 marks here. So please copy these two triangles in your notes. Label them GHJ and MKL, sides of 9, 12, and 15 over here, side lengths of 12, 16, and 20. Put a little similar symbol in between them, and then be sure and label these or mark these congruent angles. All right, are you ready? I want you to find the scale factor of GHJ to MKL. Oh, it's so easy, students. It is so easy. What triangle did I put first? GHJ. I want you to find the scale factor of this triangle to this triangle. Well, whatever triangle I set first, pick one of the sides. I don't care what side. Pick this side here. 9. Write 9. And then put a fraction bar. Find the scale factor of this triangle to this triangle. Okay? Well, I chose 9, correct? What side is 9? GH? Well, here's GH right here. What goes with GH? MK? Do you see that? GH goes with MK. Here's MK. So I put a 12 in the bottom. In other words, whatever triangle comes first, you want that triangle to go in the top, and whatever triangle comes second, you put that in the bottom, or whatever polygon comes first, doesn't matter. And then you reduce this, and that's the scale factor. It's that simple, guys. So when I ask you to find the scale factor of one polygon to another polygon, whatever polygon came first, that goes in the top, and whatever polygon came second goes in the bottom. Mr. Harrod, what if we use a different side? Guys, it doesn't matter. If I used HJ, which is 12, HJ goes with KL. Well, guess what? 12 over 16 also reduces to 3/4. So it doesn't matter what side you pick, as long as you put this side with its corresponding side over here, you'll get the same scale factor. Let's try it the other way, okay? All right, you've got your picture here, so I guess I'll quickly mark these for you. But you've got this already in your notes, these triangles. And now let's do it from the other direction. I want you to find the scale factor of MKL to GHJ. Okay, let's start with MKL. Here's MKL right over there. There's that triangle. Now, which side do you want to use? I'm listening. Okay, you all said MK? Fine, no problem. So, that has a length of 12. So I put a 12 up top. Now, what triangle comes second? GHJ. What side goes with 12? Wouldn't it be 9 over here? Sure it would be. So 12 over 9. If you reduce that, what do you get? 4/3. Isn't that the inverse of what we had over here? Yeah, 3/4. And then when we said, okay, we're going to find the scale factor putting this triangle up top, we get the inverse, 4/3. So when I ask you to find the scale factor, whatever polygon comes first, you put that side up top. Whatever polygon comes second, you put that side in the bottom. Reduce, and that is your scale factor. Now that's pretty easy, okay? Really, really is. Okay, I'm going to give you a second. Let me check my stopwatch here to see how we're doing. Okay, class is probably getting close to being over here. Let's quickly go on. I'm gonna keep going, and then you all will probably just end up stopping the video and don't worry about watching it tomorrow. But I want you to turn to page 366. We're just going to go until the bell rings and you can stop the video. Page 366, numbers 1 and 2. Would you please quickly turn your books to this page here? Thank you. Page 366, numbers 1 and 2. And the directions say to do this. We're going to do these two in your notes. Determine whether the 1 and 2 at the very bottom of the page. So 366, numbers 1 and 2 at the very bottom of the page. All right, number 1 set, or the directions say, determine whether the polygons are similar. If they are similar, write a similarity statement and find the scale factor. Okay, look at those first two triangles, would you please? We have 3 congruent angles. Y has 2 marks, E has 2 marks, A has 1 mark, B has 1 mark, Z has 3 marks, and F has 3 marks. So for problem number 1, we do have what? Congruent angles. That's fine. Now let's see if we have proportional sides. YX is 6, and I'm going to put that over ED, which is 9. And then YZ, do y'all see YZ? YZ is 12, and that would go over EF, which is 18. Put an equal sign here, they should be equal. And now the only other side I haven't used yet is XZ, and XZ is 8, and that would go over DF, which is 12. Now let's reduce these and see what we get. Well, if you reduce 6/9, you get 2/3. If you reduce 12/18, yep, you get 2/3. Now we're not home free yet. Let's see what happens here. If you reduce this by 4, you get 2/3. Booyah. So the answer is yes, they are similar. Hold it, hold it. That's not all we're doing. Now they want you to write a similarity statement. So we do the first part. Yes, they're polygons. Now write a similarity statement. We've not done that yet, so you better pay attention, okay? We have not done that yet. All right, here we go. We're going to say triangle. Now look at your first triangle. We're going to call it triangle X. We're going to call it YXZ. So triangle YXZ. Now please don't put congruent. These two triangles are not congruent. They are similar. So we're going to put triangle YXZ is similar to triangle. Now stop. What was the letter you put first over here? Y. So let's go to the other triangle, and which angle matches up with Y? Well, if you said E, you're correct. Now what's the second letter? X. All right. What angle goes with angle X in the other triangle? D. And of course, then the only other angle left to use would be F. There, you did it. You wrote a similarity statement. of those two triangles. Very good. And now find the scale factor. Are you ready? Let's see if I had these. I did not. Okay. It says write the scale factor of figure B to figure A. So do you see figure B? Look right here in this circle. I'm going to do it for you. Let's find the scale factor. It says from, I'll read it right out of the book, find the scale factor of figure B to figure A. Okay, which figure did they say first? Figure B. So pick one of the sides from figure B. I'm going to use EF, which is 18. Okay, and they said find the scale factor of figure B to figure A. So now we go to figure A and we find the side that matches up with 18, which is 12. Now we're going to reduce that and we get 3/2. So there's the answer. That 3/2 is the scale factor of figure B to figure A. Now if they would have asked for the scale factor from figure A to figure B, 2/3. So it all depends what they're asking you to do first. Now let's quickly, number two, they're at the bottom of the page. Well guys, we can see right away they're not similar. How do you know that, Mr. Earhart? Well, please watch. Do you see side RQ is 9, and we would put that over 6, and then side PQ is 12, and we would put that over TU, which is 10, and now they should be equal. Well, let's reduce this. We get 3/2, and let's reduce this. We would get, ooh, not good, 6/5. Those two fractions are not equal, thus those two rectangles are not similar. Alright, I'm going to continue on. You're about ready to probably stop the video, but I do want you to keep listening to this until the bell rings. Alright, let's take a look at this one right here. Okay, we're going to find the value of x. Okay, students, the value of x. Now we know these two triangles are similar. I'm writing that up here right now, and I'm telling you this angle is congruent to this angle, and this one with this one, and this one. Alright, we're going to find side x. Okay, now think about that. This is so easy to do. Look, side 10 goes over side 15, and then put an equal sign. Side 8 goes over side 12, put an equal sign, and then side x goes over side 9. Look at that. Well, Mr. Earhart, which ones do I set equal? Look, guys, it doesn't matter if you say 10 over 15 equals x over 9 and then solve that, or if you say 8 over 12 equals x over 9. It doesn't matter. You get the same answer. Watch. 10 times 9 is 90. Remember how we did this? We learned this already. 90. And then 15 times x is 15x. Divide by 15, and what do you get? 6. Now let's do it over here. 8 times 9 is 72. 12 times x is 12x. Divide by 12, and 6 equals x. So very good. By the way, can I show you something really, really, really cool? And you need to see this. Please don't zone out. Now that we know x is 6, add up all of the sides. What is the perimeter of this triangle right here? Add up all three sides. What's the perimeter? 24. Add up this perimeter right here. 36. If you reduce that, what do you get? Remember, this is the perimeter over the perimeter. If you reduce that, what do you get? 2/3. Well, guess what? If you put a 6 right here for the x, if you reduce all of your sides, what do you think you get? Yep, that's right. You get 2/3, 2/3, 2/3. That's not a coincidence. That will always work. Whatever ratio these sides are will be the exact same ratio of the perimeter. I think by now class is probably over, so I'm going to go ahead and stop. I had so many more problems I wanted to do, as you can see here. Just quite a few I wanted to go over with you, but that's fine. Tomorrow when you walk in the door, you have a really big homework assignment to work on, and you'll work on that the entire hour. Thanks for listening. Hope you guys have a great day.